I even like the music, even though I don't like the composer Hans Zimmer. I don't like it. Well, not true. I didn't like Inception, the soundtrack, but I did like Interstellar, and I like this one, Dune. Yeah, but I was one for Inception was so disappointing. So anyway, Archimedes principle. Okay, another example is very important. Health sciences is osteopenia and osteoporosis. Osteopenia and osteoporosis. Osteoporosis gives you an idea of porosis. Because osteo means bone in Latin, I think. Well, it's Latin. And pore is a pore in the bone. So you have a bone. It's a problem. It happens when aging for unknown reasons. Bones become porous, and that's a problem. That's a problem. Why? So, in principle, the calcium, the crystals of calcium, I don't remember. It was like a kind of apatite. Yeah, no appetite. Apatite is the mineral that is formed of calcium in the bones. Is constantly forming and disappearing, and forming and disappearing, it's balance between forming and disappearing. You have a balance, but for unknown reasons, I don't know what causes it. I don't think that it's known in science, so it's not only me. This balance, yes, this is forming and this is disappearing. Is unbalanced and it disappears faster than it forms. So there's a deficiency. Deficiency, I understand. And this deficiency causes the bones becoming porous, losing density, losing density. And then osteopenia is a light form, but wearing, and the treatments are related to vitamin D, because vitamin D is related to bone formation. I don't know how, but vitamin D. And then osteoporosis is so the classical example of osteoporosis is a hip breaking, okay? Hip socket, I think, breaking. People in the past thought that people fell and break the bone, and then now they discover that they break the bone first and then they fall. And yeah, so this is measured by using radiation. Yes, I don't know. I remember there was a isotope, a radioactive isotope, and then I think it's by the absorption of the bone. You have calibrated, and then because radioactivity, the shield for radioactivity is the density of the particles. That's why, for instance, lead this is radioactivity. For instance, X-rays. If you put thick layer of lead, it's absorbed, and it's because lead is very dense. So density is related to absorption to radioactivity. So this is the way to measure the density of what I was going to say. Something about it. One problem with osteoporosis is people bending the backs, because the bone is not strong enough in the column, is not strong enough for the weight of the upper part. So with time, it starts to bend, and so osteoporosis causes this. I've seen many people doing this and even worse. So tomorrow I'm going to use density to explain, because density is used for quality control of potatoes, because the density is related to potato has contain water, so, and then there's dry matter. There's a balance between dry matter and water content, and depending on water content, this ratio is better for frying or for baking, and so by measuring the density, you're able to see before doing it, to say, okay, this is better for that, or for this, or for that. And then I'm going to use density also to make coffee preparations. I'm going to prepare a coffee with brandy here, and then here coffee, and this is the coffee, right, and this is the brandy, and then the liquids won't, if you do it well, if I do it well, they won't mix because of the density, so that's nice, because let's see, the coffee is less dense, so it flows like a ship on top of the brandy, which is more dense. Okay. This is a good example, and then there's another example, but I'm too tired to say. Okay, water. What the maximum density of water occurs at 3.98, roughly 4 degrees. Is the biggest density. So when a river freezes, first it has to be at 4 degrees. All the depth must be at 4 degrees. So that means a lot of cold. Okay, so all must be at 4 degrees, because when the top layer is at 4 degrees, it sinks, and then the upper layer is not 4 degrees. So first it's going to go deep, the cooler part, and then it starts freezing, and then when it freezes, ice is less dense, so it covers the surface and isolates. It's a kind of isolation. Okay, ice, like igloos are made of compacted, it's not ice, but similar, it's compacted snow. But anyway, it's an isolator, so here you can have when water at 4 degrees or less, but it's not solid. Okay, and then slowly becomes to freeze from up to down. Then must be very cold for to cool a lot. Okay, I've seen that in a river in Lapland. We went for a campaign of measurement, and the depth was 1 or 2 meters. Was frozen because it was super cold, like 30 degrees below 0 Celsius. So, and then I'm going to make some bread. The idea is the weight. My bread has like a sponge because it's full of air, so it changes density. Okay, so this I'm going to do tomorrow. Sorry, but I can't. Tomorrow I'll try to record I don't know what to do tomorrow. Okay, that's enough.